Hello, this is simply about networking protocols, and today I'll tell you about relations between ECMP, LAG, and MLAG, also known as MCLAG, VLAG, and many other abbreviations. In this video, I remind you about ECMP and LAG, and tell you how ECMP relates to LAG and ECMP relates to MLAG or MCLAG. How you remember from previous videos related to OSPF, each topology of autonomous system or OSPF area can be represented in the view of graph, where those costs are administratively configured costs or administratively configured system that calculates cost depending on what supports your actual vendor of the environment that is part of this topology. And this cost signals about cost of transmitting traffic between devices from top to bottom. Well, yes, we would expect that this number will be symmetric, and cost of the transmitting traffic between R1 and R3 same as transmitting traffic between R3 to R1. Well, maybe not, and you should remember that this may be not. In this particular video, we are not reviewing traffic from R3 to R1, so we are using only those numbers, and each segment has only one number, and we're calculating only it. So we can calculate cost of traffic transmit from R1 to each device or each instance in our autonomous system or OSPF area, and this will be sum of costs for each hop that traffic should pass during its travel from R1 to specific entity. Those costs can be added to the table, and all explicit possible paths with all possible next hops, because as you remember from a video about routing transmits traffic to the next hop only. So anyways, anyhow, no matter where is our final destination, traffic by the routing will be transmitted either to R1, R2, R3, R4, R5, which are next hops for R1. Then, having cost of traveling from R1 to every other entity in our topology, we are assigning next hops where this actual path starts, and we can select how many possible path start we have in order to transmit traffic using the path with lowest possible cost. In case there is only one path with lower possible cost, it is selected, but it's still possible variants where lowest possible cost has multiple paths, or actually multiple paths have lowest possible cost, and those paths start with different next hops. That is condition for appearance of a ECMP group. Then on our graph we can remove those paths or those hops that are not used in any path and operate with remaining. And ECMP group can appear or configures or works only in case traffic is transmitted to specific destination and has multiple next hops to start with. Then ECMP group works, traffic is distributed between those next hops, going to its final destination. Even if we have situation where traffic can start it's travel to some specific destination with, again, several next hops, but in our system we selected only one path, there is no ECMP group. Only one next hop will be selected, only one path that we have, and traffic goes to the final destination only through one route. Thus, ECMP group depends on the final destination and availability of the multiple next hops, plus, of course, topology of the system, autonomous area or SPF area. Good. If topology of the system has changed, then dynamic protocol of the dynamic routing reacts on that, recalculates all the passes, we receiving new possible paths or set of new possible paths, and depending on the topology change, ECMP group can change, can disappear, or another ECMP group can appear in some cases, some conditions. Let's introduce LAG into our topology. For better visibility, let's introduce LAG that connects our router R1 with one of the next hops R3, for example. The only influence that LAG could have on the topology itself is somehow reduce the cost if administrator wants to do this, or the configuration that administrator applied on the autonomous system or SPF area will do this since LAG appears, because LAG now has multiple links, so traffic definitely will reach R1 to R3. This is much better path now because it has additional possibilities to additional guarantees to be executed, and also we can transmit much more traffic in same time because we have multiple links where traffic can be transmitted in parallel. But well, this is not necessary for our experiment. Let's have it still having 3 as before, just to display that depending on the LAG, ECMP LAG has no influence on the ECMP group. Still, ECMP group depends on the destination, topology, and sum of costs for each route, for each possible path to the destination. If LAG is the part of one of alternate paths, and this path has same minimal cost, this next hop will be selected as part of the ECMP group. That's it. LAG has no direct influence on ECMP group. So ECMP group depends on destination. If we working with traffic that destined to another entity in our topology, another next hop will be selected based on the path, actually. So we treat LAG in scope of ECMP like just another version of the link with better capacity. That's it. Yet another port to be used. Also, LAG, its appearance doesn't change topology that much if cost haven't changed. Changing of the host or of the cost changes topology. We can have multiple LAGs in our system, and still ECMP group will depend only on path costs to each entity and destination of the traffic that system works with, processes right now. LAGs will be selected, won't be selected. Also on topology change, influence on ECMP group appears, but not on the LAG. LAG still appears and still transmits traffic if we need to send traffic between R1 and R3 only, for example, for any reason. But MLAG or MCLAG or VLAG, whatever you call it, is different. MLAG changes topology of the system. Once MLAG is introduced, we don't have anymore two alternate hops. We're treating both of those devices as single next hop that changes our topology from our root device point of view, and now in our table of all possible paths we have for each instance only one next hop. Thus ECMP group is impossible physically. So introduction of MLAG changes topology, and ECMP group, as ECMP group depends on topology, modifies and can disappear, appear on different paths, or can be changed and use different next hop depending on actual topology after introduction of MLAG. That simple. Thank you. Have a great day.